The simulation recreates the extreme conditions of an Arctic winter. Key environmental factors include intense cold and strong winds. These conditions posed significant survival challenges for the Vikings. Understanding these challenges highlights the ingenuity of Viking solutions. The simulation aims to provide insight into the hardships faced in the Arctic environment. Viking longhouses lacked modern heating systems. These structures also lacked modern insulation techniques. The absence of these features highlights the importance of the longhouse's inherent thermal properties. Understanding these properties is key to appreciating the longhouse's design. The longhouse design adapted to maintain habitable temperatures. Longhouses are designed with unique architectural features to withstand harsh polar conditions. The structure resembles an overturned ship, characterized by its curved walls. This specific design is purposed to deflect polar winds effectively. The curved shape minimizes the direct impact and resistance from strong winds. This aerodynamic design contributes to the structural integrity of the longhouse. The form reduces the overall stress exerted by the environment. The walls are constructed as thick, multi-layered structures. These walls feature two outer layers that form the exterior and interior surfaces. The space between these layers is filled with compressed peat. The compressed peat acts as a natural insulator. The peat traps air, providing insulation comparable to modern materials. Peat is composed of soil and roots, forming a unique structure. This structure traps a multitude of air bubbles within the peat. The trapped air bubbles create an insulating barrier. Air's insulating properties are maximized when it remains still. The immobile air within the peat significantly reduces heat transfer. Therefore, peat serves as an effective natural insulator due to its composition and trapped air. Longhouses are traditionally divided into distinct living and stable areas. Livestock are housed indoors, sharing the same roof as the human inhabitants. A permeable wooden partition separates the living space from the animal enclosure. This design integrates animal husbandry directly into the domestic environment. Cows in stables generate a significant amount of heat. This continuous heat production functions as a biological central heating system. The heat generated by the cows naturally rises. This rising heat warms the living area above the stable. The stable acts as a heat source for the longhouse. This natural process reduces the need for artificial heating methods. The living area is positioned above the stable in this heating design. Warm air, generated by the animals in the stable, naturally rises. This rising warm air heats the elevated living space. This demonstrates a natural convection heating system, utilizing the principles of thermodynamics. Vikings designed their houses to retain heat effectively. Houses were treated as thermal armor, minimizing heat loss. Potential heat loss points were carefully sealed. This ensured a stable and comfortable indoor temperature. The absence of windows is critical for maintaining effective insulation within a structure. Windows inherently compromise the thermal barrier of a wall. They act as points of significant heat loss due to their lower insulation value compared to solid walls. By eliminating windows, a continuous and more effective insulation layer is achieved. This results in improved energy efficiency and reduced heating or cooling costs. Buildings in cold climates employ specific design features to minimize heat loss. Low and heavy doors are used to reduce the amount of cold air entering the structure. Vestibules function as airlocks at entrances. Airlocks prevent cold air from directly infiltrating the main living areas, maintaining interior warmth. A vestibule acts as an airlock at an entrance. The outer door must close before the inner door opens. This prevents direct airflow from outside to inside. It minimizes the entry of cold air into a warm interior. The vestibule thereby conserves energy. It maintains a more stable indoor temperature. A longhouses is a long hearth located inside a longhouse. It serves as a central heating source for the longhouse. The longhouses typically spans 10 to 15 meters in length. It is positioned at the center of the longhouse structure. The central location ensures even heat distribution throughout the interior. Stones around a hearth are used for heat retention. These stones absorb heat during the day, particularly when a fire is burning. The accumulated heat is then gradually released throughout the night. This radiant heat helps maintain a stable temperature within the longhouse. Smoke accumulates under the roof of a structure. This accumulation creates a layer of warm air. The warm air layer provides additional insulation to the building. Smoke saturates the wooden frame, protecting it from rot and insects. A leora is a designed opening in a roof structure. Its primary function is to regulate smoke ventilation within the building. The leora prevents the excessive accumulation of smoke. This regulation is crucial for maintaining air quality and visibility. Simultaneously, the leora is designed to retain heat within the structure. This dual functionality optimizes both ventilation and thermal efficiency. The roof is constructed using multiple layers to ensure weather resistance. Birch bark is utilized as a primary waterproofing layer in the roof construction. A layer of peat is applied over the birch bark, providing additional insulation and protection. This combination of materials creates a durable and effective roofing system. Peat layers are used as roofing material on longhouses. Over time, the peat layer on the roof naturally accumulates organic matter. This accumulation leads to the growth of grass and other vegetation. The vegetation cover adds an additional layer of insulation to the roof. This natural insulation helps regulate the temperature inside the longhouse. During winter, snow accumulates on gently sloping roofs. This accumulation forms an insulating layer over the roof surface. The snow layer acts similarly to an igloo's insulation. It helps maintain the roof structure at a temperature around 0 degrees Celsius. This insulation minimizes heat loss from the building through the roof. Snow accumulation on a roof acts as a natural insulator. The accumulated snow forms a barrier against external temperature fluctuations. This insulating layer helps maintain a more stable internal temperature. The stable temperature is maintained even during severe weather conditions. The snow reduces heat loss from the building's interior. This insulation effect contributes to energy efficiency. The longhouse design incorporates effective insulation techniques. This insulation helps regulate the internal temperature of the longhouse. The insulation minimizes the impact of external temperature fluctuations. This results in a more stable and livable indoor environment. Longhouses integrate multiple elements for sustainable living. Peat walls provide insulation and structural support. Animal heating utilizes livestock warmth to raise indoor temperatures. Airlocks minimize heat loss during entry and exit. Snow insulation further enhances thermal efficiency. The Viking longhouse was more than just a dwelling. It was a highly functional structure. It served as a survival machine, providing shelter and security for its inhabitants. The longhouse design was deeply integrated with the surrounding environment. Building materials were sourced locally, minimizing environmental impact. The structure was carefully designed to withstand harsh weather conditions. The longhouse exemplifies Viking ingenuity in adapting to their environment. Vikings adapted their construction to local resources. They used available materials efficiently. Vikings also considered climate conditions in their building practices. Their methods were designed to work with, not against, nature. This approach ensured sustainability in their settlements. Viking construction exemplifies resourcefulness and environmental awareness. Viking thermal engineering principles offer valuable insights for modern sustainable building. These principles emphasize energy efficiency, reducing the environmental impact of buildings. Application of these principles promotes harmony between buildings and the environment. Modern buildings can integrate Viking-era strategies for natural heating and cooling. This approach contributes to creating more sustainable and eco-friendly living spaces.